Hello and welcome to part 8 of the LinuxKI video series. In this session, we'll be reviewing the CPU profile report, which provides insights on the top kernel functions executing during the trace. The CPU profile report is automatically generated by the KI-all script along with other reports listed here, including the reports previously covered. The CPU profile report can be found in the .txt file beginning with KI-prof. The CPU profile report is based on the hard clock trace event, which is collected on each CPU core approximately every 10 milliseconds. This report provides a system-wide view of the top kernel functions that are executing, along with their corresponding stack traces. The CPU profile report is especially helpful when troubleshooting problems when higher than expected system CPU is observed. Note that the hard clock events and stack traces are only collected with the LinuxKI tracing module and are unavailable if ftrace is used. Also, the hard clock trace events can be delayed if the operating system is executing in critical code, or when an idle CPU is halted due to entering one of the idle C states. So percentages may not be as accurate as what is seen in the CPU and run-queue analysis report we looked at in part 7. The first section provides a summary of where the hard clock trace events occur, whether it's in the user code, system code, interrupt code, or it's idle. The second section provides the kernel functions where the hard clock trace events occurred. This section can help identify hot kernel functions. Note that all the user functions are collected and listed as unknown. In this example, the mutex lock and mutex lock slow path functions represent over 5% of the kernel profile events. While this may not seem like much, the key is figuring out if the CPU usage by the function can be reduced or eliminated. A small system-wide percentage may have a bigger impact to a few key threads in the application. The next section provides a full kernel stack trace where the hard clock events occur. Note, we can identify the busier code paths and not just a function. Also, a busy function can be represented by multiple stack traces. Note the mutex lock function shows 3 distinct code paths from the write, lseek, and read system calls. The CPU profile report also provides per CPU statistics, similar to the global statistics previously mentioned. This could be important if a small set of CPUs encounter the same hot kernel functions. Finally, the report shows the top tasks or PIDs that were executing in the kernel code and the top functions that were executing for each task. This same information is found for each task along with the stack traces in the PID analysis report. For additional information on LinuxKI, be sure to visit the LinuxKI wiki page. Thank you for watching and be sure to join us for subsequent video sessions.